A very good morning to you, and thank you for being with us for the fourth and final day of the Kuiper of VMware Big Breakfast series. The idea of this webinar series was to satisfy your appetite for information, specifically to show you how you can deliver a secure, consumer-like experience on any device with VMware. Our aim was to show you how to create an anywhere organisation to empower every employee, manage it all from the cloud, and finally, wrapping it all together today, establishing zero trust security for your new digital workspace. Don't worry if you missed any of our previous sessions this week. I'll explain how you can watch all of them on demand at the end of today's webinar. I'm Stuart Hall and I'm Director of Kuiper. As always, I'm joined by my colleague and Head of Sales Neil Jelly, plus two of the best technical minds VMware has to offer. At Kuiper, we're dedicated to universally embracing IT solutions by acting as a broadline provider in every aspect of IT. We aim to go above and beyond, and that through the solutions we provide, we can have a massive impact on the way our customers do business, changing them for the better. We cater for everything from standard hardware and software, right through to telecoms, managed services, and even digital signage. Our partnership with VMware goes from strength to strength each year, and as their portfolio has expanded, we found that our customers are building upon their existing investments and taking full advantage of what VMware has to offer. This series has been put together based upon the questions that our customers most frequently ask us, and we're delighted that VMware have supported us all week. Time to switch gears now, and here's Neil to ask today's big breakfast, big question. Over to you, Neil.
Thanks, Stuart, and good morning, everyone. And today, for the final time this week, our big breakfast question is: how can we get real-time access to all devices, applications, and user behavior, but without having to spend a fortune on dozens of security solutions? We need to ask this question because, thanks to the monumental changes that happened with COVID-19, the number of endpoint devices that IT professionals are having to manage has grown beyond all expectations. Not only that, but the way in which the network infrastructure is organised has had to flex to accommodate home Wi-Fi, local broadband, and sharing networks, and potentially devices within a household. With this in mind, the threat vector has also changed, which has made networks far more porous and easier to penetrate. As with our previous sessions, VMware has sent us two of the finest people to help us address this question, and it's my pleasure to introduce to you Paul Whitton, End-User Computing Solutions Engineer Manager for UK and Ireland, and to present Darren Hirons, Senior Solutions Engineer for Digital Workspace. Gents, over to you.
Thanks, Neil. Good morning, everyone. I'll just share my screen. Okay, so yeah, as the guy said, welcome to day 4. We're going to cover intrinsic security today. For anybody that's just joined today, missed any of the previous days, yeah, I'm Darren Hirons, and I will be leading you through today's topic. As we've done on the other days, I just want to quickly recap on the components of the Workspace One solution and just recap on what we've talked about in the previous 3 days. So on the first day, we looked at this blue layer at the bottom, what we refer to as the access layer. This is the layer that the hub services runs in and what typically the layer that the end users will interact with. Moving into the second day, we looked at this green layer, which is the device management layer, or what we call the unified endpoint management layer. We've touched a couple of times on the intelligence layer and about how we can collect and harvest and doing more intelligent things with this data that we're collecting. And then yesterday we talked about everything that was related to VDI and virtual desktop and app delivery. So today's topic is really going to cover a little bit of all these things because security touches every aspect of every end user computing interaction that end users have. So we're also going to touch on the add-on for Workspace One Security today as well. So let's get going. So first of all, let's reassess what the challenge is. Neil touched on it just then. But what we've seen really is that historically people, when it came to end user computing, people would give devices out to their members of staff, and typically they would secure those by putting them on the corporate network, locking them down with policies, and getting their users to authenticate with domain accounts. Everything was very enclosed within the company data center and within that company network. But as time's gone by over the last few years, especially in the last 12 months, this has totally changed, and this perimeter boundary is completely dissolved. We've got people working everywhere now, mainly at home. We've got more and more people using different types of devices, and we've got to think about how to secure those, how to patch them within a good period of time, how to get updates to them, how to change policies on the fly. And also where the applications reside has changed as well. And I touched on this earlier in the week, but applications now can reside anywhere. Some of them could still be in the data center. Some of them could be mobile apps. Some of them could be SaaS applications that are delivered from the cloud. So it's not as simple as just securing your perimeter boundary anymore. You've got to think about securing these devices, these users, and the networks wherever these users are. And that's what we're going to try and cover today. So what we try to do with Workspace One and our zero security principles are focus on 4 key areas. First of all, we want to focus on securing the authentication of the user. We also want to ensure that all the endpoints that are out there, whatever type of device they might be, wherever they might be residing, we want to check that they are compliant with what policies we've pushed to them. We want to make sure that any applications that are out there and that are being used are protected from either deliberate or accidental data loss. And we want to check that the right people on the right devices can only get into those applications. And then finally, we also want to secure the network. So when people are tunneling maybe back into your network through a VPN, etc., we want to make sure that that's done in the most secure way. And then finally on this slide, we also want to be able to wrap all this up. We want to collect all this data around users, around endpoints, around apps, and around the network. And we want to be able to do something meaningful with that data. We want to be able to use it to further secure the environment. We want to use it to do remediations of endpoints, perhaps, or we want to be able to use that information to maybe stop users from accessing applications if they're considered too high risk. So I'd just like to spend a couple of minutes talking about Workspace One Access. So this is the bit of the Workspace One platform that powers that blue layer, that access layer that the users are accessing. And this is the layer that we talked about on the first day that delivers the app catalog, people search, all those things. It does single sign-on, so there's only one sign-in required by the end users to get access to all the content. But it does do conditional access policies on all those application types. And we can also do things like deliver different applications like virtual apps, virtual desktops, SaaS applications, mobile apps, etc. And it's got multi-factor authentication built in. And we're going to touch on a lot of these things as we go through today's session. So what Workspace One Access does in that access layer is it acts as like a gatekeeper for all the apps and data. So when your end users try to access a particular application, the Workspace One Access platform is making an assessment of the user, the device, and the network. And based on rules that you set as the administrator, will determine whether that end user in those circumstances is allowed to access that application and that data. So in this example, a user might authenticate to Workspace One, so they've proved who they are. So we trust them as a user. Workspace One Access will then assess whether their device is compliant by talking to Workspace One Unified Endpoint Management. And if that device is compliant, that's 2 ticks in the box. We trust the user and we trust the device. Finally, it'll check whether there are restrictions on whether that application that the user is trying to access is allowed to access it from the network they're coming from. And in this case, they might be on the company network and it's considered to be trusted. And so in this circumstance, the end user, the device, and the network have all been assessed by access, and they've all been deemed to be trusted. And so we allow that user access to any of the applications within the catalog, or any of the applications that meet that conditional access policy anyway. If, however, that end user goes somewhere where they're on a non-trusted network, there may be certain applications that we don't want them to access. So based on the conditional access policies and assigning the right ones to the right applications, by doing this, we could stop the user from accessing sensitive data from a non-trusted network but there may still be some applications in the catalogue that we may still want them to be able to access. Maybe public websites, for example. And this is all possible with the Workspace One Access platform. So let's start going through the 4 areas. Let's first of all take a look at users. And we want to really be able to check and authenticate those users. And when they prove who they are to the Access platform, we want them to be able to do that in the most efficient and most trouble-free way possible. And so really, one of the key areas is we're trying to look at them authenticating using passwordless authentication. Passwords are, they're widely regarded as insecure, they're easily crackable, and users forget them, they cause problems with service desk tickets. It would be far, far easier and far more secure if we could get rid of them. So we're starting to introduce alternate ways that users can log in and prove who they are. We've also got tools like multi-factor authentication if we want to step up the authentication and make certain applications more challenging to access. We've got these conditional access policies which we can reassess the user every time they try and access a different application. And we've also got this concept of dynamic risk scoring, and we're going to cover this towards the end of today's session. But essentially, we build up a picture of exactly what the user's doing, and based on what they're doing and whether their behavior is seen as risky or non-risky, we'll assign them a score, and that score will dictate what they can access and what their login experience is like. So some examples of passwordless authentication are things like Face ID, fingerprints, biometric access. We've also got some tools like mobile SSO. So if you're on an Android or an iOS device, we can log users in without username and password using Kerberos and our Tunnel technology. We've also got the multi-factor authentication, which of course is passwordless. And we can log users in with a certificate if they're on a trusted device. We simply deliver that certificate to that device, and when the end user tries to access, the certificate authorizes their access to the platform. And when it comes to actually authenticating that user, we can point and we can look to authenticate that user from a number of different places. So once the user puts their credentials or however they want to access the platform into the access portal, we can go off and check in different places that they are actually who they say they are. So we can connect the access platform to the likes of Okta, Azure AD, Ping, or even your local Active Directory. So when the user logs in, we seamlessly check and verify that the credentials that they're providing are trusted. So we can integrate with lots and lots of different platforms out there. And I mentioned this a few times, but we have, of course, got the multi-factor authentication built into the hub. So if a user tries to access a particular application that's got a policy on it which requires MFA, or maybe their behavior has changed and the platform's intelligently stepped up their authentication to challenge them, they'll simply get a pop-up on their mobile device. They'll be able to see what's coming in, who's requested what, and they'll know whether it's them or not. They simply click approve or deny, and we can enhance that protection by also requesting Face ID to further prove who they are. Once that's approved, it'll authorize them to access the application. So when the user tries to access the platform, if the application requires it, or if they're challenged for it, or maybe if the device is non-compliant, for example, we can challenge them for verified before we allow them access to the applications. Let's move on and take a look at endpoints. So we talked on the second day about how we manage the endpoints with Unified Endpoint Manager. Really, when it comes to securing endpoints, really there's 3 key areas. We want to be able to manage the devices wherever they are and make changes to them wherever they are as quickly as possible. We don't want to be relying on devices having to come back to the corporate network to make configuration changes. We need to be able to check at all times that those devices are compliant. We even want to be able to do that compliance check when the user tries to access applications. We want to do it in real time on the fly. And then if there is anything wrong with the device, really, we want the platform to remediate it. We don't want the end user to have to bring the device back to IT. Certainly not right now anyway, because that's more and more difficult during the pandemic. So we want to be able to automate certain actions to be able to do device remediation. And when we look at this green layer, we need to be able to do this throughout the entire life cycle of the device. And this is what we can do with the Unified Endpoint Management platform. And this integrates tightly with the Workspace One Access platform. They're always talking to each other, they're exchanging data, they're exchanging the health posture of the devices, so Access knows at any time how healthy or unhealthy or compliant, non-compliant a device is. And so if a user tries to access perhaps on a mobile device, which is a managed device and it's in network scope, the conditional access policy might allow them. If they're on a managed device, but their network's out of scope, it might block them. But if Workspace One Access requests the health posture for the device from UEM, and it finds that the device is jailbroken or compromised, it will simply block access. So the platform's intelligent enough to know when the device is non-compliant, and it will block access if that's what the policy tells it to do. And we can do that on different types of devices as well. So we can do it on Windows 10, for example, as well. So what will happen is exactly the same thing. An end user will go into the catalog, they'll click on an application. Access will quickly go to UEM and check whether the device is compliant or not. If it is compliant, it'll allow them into the application. If it's non-compliant, it will block their access and they'll get an error message. Those error messages can be customizable as well. And what we're actually checking for can be customized, so we can check whether the device is booted securely, whether it's got BitLocker enabled, whether it's got antivirus and firewall turned on, has it got TPM enabled, is it on a certain Windows version? And we can check and we can validate all these things depending on how you want to deem it as compliant. So when it comes to conditional access rules with devices, we have a few different options. Firstly, if a user tries to authenticate and they do that successfully and they're on a trusted network, we'll assess the device and check if it's compliant. And if it's compliant, we'll allow the user to access the apps and data. If the device, however, is non-compliant, we can then block access to certain bits of apps and data, depending on those those conditional access rules. What we can also do with devices is we can check whether the device is managed or not. So is the device managed? If it is, we can allow it in because we trust it. If it's unmanaged, again, we can block access to those applications. And we can also check by device type as well. So there might be certain applications that you only ever want to be accessed on a particular device, maybe because of their form factor, etc. So we can also specify within that conditional access policy the type of the device that's allowed to access as well. When it comes to applying security policies to endpoints out there, we have a really cool feature for Windows 10 devices. It's called Workspace One Baselines, and these can be applied using the Unified Endpoint Management platform. And what baselines are is they're a common set of security standard templates that we have baked into the platform. These are essentially made up of group policy settings, and they can be applied over the air. So we're not relying on them being connected and delivered from the Active Directory domain. We have several standards in there. We have all the Microsoft standard security templates for all the different versions of Windows. We also have the CIS benchmark standards in there as well, which are the industry standard security templates. They can all be applied over the air regardless of where the device is. One key thing, by the way, on that slide as well is that we can also track the compliance of whether the device is adhering to the baseline or not, which is something that's very, very difficult to do with group policies. So if you're applying the same Windows security policies or the same CIS benchmark policies using a group policy, you can push them out, but you don't really ever know if they're compliant or not. With the baselines, you can check which devices are compliant and non-compliant at any time in the platform. Let's move on to apps. So when it comes to apps, we're really concerned with two things. We're concerned with stopping either deliberate or accidental data loss from that application. And we're concerned with the conditional access policies allowing or disallowing access to that application based on the conditions at that time. And when we're talking about data loss prevention, what we're really talking about is stopping data, or either authorized or unauthorized, leaking out of that application or out of that endpoint. So in this example, we might have an application which has got a DLP config applied to it. And that DLP config allows the camera of the device to integrate with the application, but it might block the end user from using the clipboard, and it might block the end user from taking a screenshot of the app. When it comes to attachments within or pieces of data within that application, we can also control those. And we might choose to block any attachments being sent anywhere else other than the application. What we can also do though, is we could also choose another application which we do trust. So the application can exchange data with this other particular application. And these are all controlled through these data loss prevention policies. And we have lots of, platform specific data loss protection policies across all the different platforms. So, for Android and iOS, we've got things like Intune app protection policies for Office 365. We've got the SDK out wrapping we can use. We've got restriction profiles. In Windows and Mac, we've got things like restriction profiles and Windows information protection, etc. So we've got lots of different ways on all these platforms that we can do this DLP. And when it comes to actually protecting endpoint devices from maybe accidental loss, or you leave it on a bus, or you maybe have it stolen, we can also protect them in that circumstance as well. So even if a device is in what we called cope mode, which we covered a few days ago, where it's corporately owned but personally enabled, it might have a mixture of corporate data and personal data on it. We can do various types of device wipe. One of them is called an enterprise wipe, and in that scenario, it only wipes off the data that Workspace One UEM has placed on that device. So if we issued an enterprise wipe on that device, it only wipes off the enterprise apps and data, but leaves the personal apps in place. Let's take a look at how we might secure networks. So when it comes to securing networks, we can integrate with some other VMware technology called NSX, which is a virtual networking technology. And this is not exclusive to EUC. This can be used across all other data center products, so it can protect servers, etc. as well. But it has some really cool features when it comes to protecting end user compute. So we can use this technology to protect and put a virtual firewall around each VDI desktop machine. And this virtual firewall doesn't exist in the desktop itself. It's not a piece of software that's installed with a firewall in it. It's a virtual firewall which runs inside the hypervisor. And there is one for every single VM that a user might log into. And what's really cool about this is, unlike physical firewall policies, which are done by source IP, destination IP, and port, these are dynamically assigned and they follow the end user around. So the firewall policy is assigned to the end user. So when an end user signs into a virtual desktop, the firewall policies that are assigned to that user are applied to that desktop. And as we saw yesterday, when an end user typically logs out of a VDI machine, it's deleted. So in the old-fashioned physical firewall rule scenario, that wouldn't work because their IP address would change and their rules would not work the second time. In this scenario, because they're assigned to the end user, no matter which machine they log on to, no matter what IP address they get consistent firewall rules that are applied to them. And what we can also do with this technology is we can use it to stop certain desktops from talking to other desktops, certain pools from talking to other pools, and we can control which VDI machines can talk to which servers as well. And one really good example of where this would really add protection is during the big WannaCry attack, where there was the exploit was spreading between virtual machines, both physical and virtual, using the SMB port. We could simply have protected that by blocking SMB communication between desktops because it's not really needed. So an example of how this works, and we refer to this, by the way, as microsegmentation. So what will happen is that an end user might be logging in from an endpoint, they might connect into a VDI machine, and they might work in the finance department. What happens is when that user logs in, they get access to their VDI machine and they get an NSX firewall rule applied, which means that they can only access the finance system and nothing else. A user from HR might log in and they might get another policy assigned, which gives them all the firewalls they need to work in the HR department. And IT might get a set of firewall rules assigned to their department. And what this means is that even if that device is compromised, there's still restrictions about what an end user could do on that device, all using this virtual firewall technology. Let's take a look now at the VMware Tunnel technology and how that can help. So when we look at physical endpoints getting remote access to your environment, we're really talking about device level VPNs. It's by far the most common method of providing remote access. And during the pandemic, we saw lots and lots of people go out and procure or scale out their device level VPN technologies. But really all that's happening with this is that you're putting a piece of software on a device and you're allowing the whole device to communicate onto the internal network. Because that's a device level VPN, it allows anything that's running on that device potentially to communicate with the internal network. This can be all the applications, which is fantastic for the end user, but this could also be something malicious that might exist on that machine. And when you've got machines off site for a long time and they've been used on a different network and they might not be able to be secured sufficiently, or they might not be patched up to date, you don't know what might be on those machines, and you might be allowing malicious code back onto your internal network. A much safer version and the more modern way to apply this use case is to do not per device VPN, but to do per app VPN. And what this does is it creates a specific VPN for just that particular application that the end user launches. And these are done dynamically in the background. The end user isn't even aware that they're happening. So when an end user on this device launches App 1 launches and it automatically creates a dynamic tunnel into the internal resource that App 1 requires. But the rest of the device has no internal access at all, only App 1. When the end user might launch App 2 launches a second per app VPN tunnel to the resources that it requires. So now we've got two applications that have got access to the resources they need, but the rest of the device can't access anything. And so on and so on. So when a third app's opened, that gets access to the designated resources that it needs, but anything else on the device which might be malicious cannot access the internal network. So this is considered to be a much safer way of providing remote access. And this VMware Tunnel technology is built into the Workspace One platform. And we can actually even further secure this by combining these two technologies together. So we can combine the per app VPN technology with the NSX technology to ensure that even if that application is compromised, maybe, we've seen recently with the SolarWinds vulnerability that, applications can be compromised and we don't know what they're going to do. So in that case, even if an application is compromised, the NSX can still restrict what it can reach on the internal network, even if the app's been compromised and told to do something else. Let's move on and look at the intelligence platform. So we've touched on this a few times, and there are a lot of different use cases for this, but obviously we're going to focus around the security use case today. So the intelligence platform is the piece of the puzzle that gathers all this data about the devices, the users, and the applications, and can do different things with that data in terms of how it presents it and automations, etc. It can do end user behavioral analytics, which we'll talk about in a minute. It can provide really good statistics around vulnerabilities that might exist on those devices, and we can also do those automations as well. So I'm going to try and show you some of these as we go through these slides and then into the demo. Now, if a customer wanted to do this now, it's really, really difficult, because often these endpoints and these applications and these users might be managed by completely different platforms. So what we'd first have to do is we'd have to export the data from all these different sources. We'd then have to load all this data into some kind of database. And even then the data might be in different formats, so that might be difficult. We'd then have to come up with some tool to maybe, manually correlate that data and try and find patterns in it. And then we've got to try and provide some way of visualizing that data, so you can a human can look at it and decide what they need to do with it. And then if you wanted to take action on any of that data, it would probably be a manual effort, or you'd probably have to code something with APIs. So doing this kind of intelligence with existing tools is really not achievable, or very difficult anyway. So how Workspace One Intelligence works is it collects all the data from the endpoints using the feed from Workspace One UEM. It has feeds from the Common Vulnerabilities and Exposures database, so it's getting all the information on a daily basis about all the latest vulnerabilities that exist across all the platforms. It can get all the information about identity, about the user's authentication, and for the apps that the end user's using Workspace One Access and the Intelligent Hub. It can also use app analytics that are built into the platform, which can check for things like application crashes, etc. And we can also pull in information from the trust network, which I'll cover in a second. But we take all that information into the Workspace One platform. Inside the intelligence platform, we aggregate it, we correlate it, and we can provide insights and we can automate out of it. So we can provide insights in the forms of dashboards and reports, and we can provide actions in terms of like emails and notifications. And we can also do automations to try and remediate issues that we might find. So we're taking all this user data, we're taking all the device data and all the application data, and we're feeding it into this intelligence platform. We take this feed from the CVE national database, which has got information about all the latest vulnerabilities. We feed that in as well, and we can scan all the incoming device data against that database to provide, immediate real-time data against what vulnerabilities each device has got. What we also provide is an open API for our trust network of partners. And this allows partners to integrate with our API, and they can also meaningfully feed data into that platform. Now you'll see at the top, one of these options is Carbon Black, which is actually the Workspace One security add-on. So you can add on the Carbon Black element to the Workspace One solution. The Carbon Black platform itself is what we call an EDR. It's an endpoint detection and response system, which is a more modern way of doing antivirus. So whereas an antivirus system works on definition files and it can only scan for what it knows, these modern EDR platforms are looking for patterns and they're looking for unusual behavior. They're much, much more efficient at picking up malicious attacks than traditional antivirus. And some of these other, partners in the trust network, they're doing other things as well. They're doing like endpoint checking, etc. So all these trust partners can feed into the intelligence platform, and they can influence also what we can take action on and what we can take automation on. So we get all that data that's coming in from all these different fields, and we can do all these different things with it. So you can do simple asset reporting, we can check patch status, we can check when a device last communicated, we can check the context of that device and the posture, we can check for OS vulnerabilities, we can check for user behavior changes, device behavior changes, and we can use all these network partners to check for malicious software that might exist out there on end users' devices. So the intelligence platform is really, really powerful. And as you can see, we can also then use that intelligence data to then take actions back to the users, maybe in the forms of notifications. We can do automations in the form of remediating devices, or maybe blocking access to applications or removing the end user's access. And an example of what this might look like in terms of a vulnerability for a device is that we get the constant CVE feed into the intelligence platform. So we have constant up-to-date information about what the vulnerabilities are that exist out there. We scan every single device that checks into Workspace One, and we check it against that CVE feed. If we identify that a patch is required, we can automatically trigger an automated patch response, and we can patch that device back to a safe state. Once that device is patched back to a safe state, we can just continue monitoring. So whereas this might have been a manual process in the past, this can all be automated with the intelligence platform. And something that we introduced in the last year or so is this concept of end user behavioral analytics. So we're actually looking at the end user's behavior and what they're doing with their devices, and we're able to assign them a risk score. So how this works is that every time an end user's device checks in, we check that device for what it's been doing, for its activity data. We are able to identify, based on a number of metrics, what we define as risky behavior on that device. And what we do is we assign each device a risk score. And then what we do is based on all the user's devices, we combine them together and we create not only a risk score for the device, but we create an overall risk score for the user. Then we can automate the response to mitigate risks associated with that end user. So here's an example of what it would look like. An end user might have a mobile device, a tablet, a desktop, and a laptop. And although the mobile device and the tablet's low risk, they may have done something on their desktop which increased their risk to medium, and they may have perhaps malware that's detected through Carbon Black on their laptop, which has increased their risk score. So the devices themselves have a risk score, but overall you'll see that at the bottom the user's risk score has been increased to high, and we can take automative action against that user now that we know that their risk score has changed. And that could be when they log into the Intelligent Hub, that could be challenging them for two-factor. It could be for sending them an email saying you need to take your device back to IT or anything like that. And obviously everything in the platform we can report on and we can create dashboards on, so we can make this data be presented in a meaningful way. And I'll show you this in the demo. Let's take a look at some real world examples of how this might look. So in this example, we've got an end user who's got a mobile device. They may do something fairly simple. They may do something like turning off Find My Phone, which in itself is not necessarily that suspicious, but it may raise their risk profile of their device slightly. What we can do then is, based on that risk profile changing, when an end user tries to access an application through the Intelligent Hub, we may step up their authentication to two-factor, just in case maybe their phone's been stolen and the thief's trying to hide whereabouts it is. And this could be verified with Face ID to stop them from just verifying it themselves. So we can enhance this two-factor so that a potential thief wouldn't be able to prove it was them. Moving on to a different example, on a Windows 10 desktop, for example, an end user might get some kind of spam email which is encouraging them to download some free applications. Let's assume this end user downloads all these applications and installs them. You'll see that they've automatically been detected and the end user's got an email saying that they've installed applications and their risk score has been increased to high. So we've used that action to make the platform send them a notification. So the end user's been told through the notification platform. From an administrative point of view, the administrator can see in the platform that that device has increased to high as well. So if we look in the risk report, we can see that the person in question, Peter, has got a phone and he's got a laptop. And you can see that his risk score for his laptop has been increased to high because he has 3 behaviors which are considered risky. If we expand that, we can look at what they are. So the first one is a laggard update, which means his device is running a really out-of-date version of the operating system. He's also been flagged as a compulsive app downloader because he's downloaded 35 applications, which is considered suspicious. And Carbon Black's also been plugged in to check his machine, and that's found 2 unusual processes, which could obviously be installed through those malicious pieces of software. From here, the administrator can click the automate button and they can simply check for occurrence of this, and they can create actions. So in this case, we can log a service desk ticket to report it to IT. We can send a push notification, which is saw the end user receive, and we could block his access to Workspace One Access. So until his device score goes down from high, we can stop him accessing any applications or data because we don't trust his device right now. Let's take a look at what this actually looks like. Let me try and do a demo. So here you'll see I'm just about to access the intelligence platform. Now, when I log into the intelligence platform, you'll see that I have several options across the top. I can check all my integrations, for example, by clicking the integrations tab, and I can see where I can integrate Carbon Black and Lookout and Checkpoint and all these other trust partner network vendors. I can also set up integration in here with Workspace One Access as well to be able to get that information on the apps and the users' authentications. I can come in here and I can create detailed reports. I just click the add button. I can pick certain categories from in here. So if I wanted to create a report on CVEs, for example, or vulnerabilities, I can click those. It also gives me some examples to choose from. If I, for example, clicked CVEs, it filters it down so I can look at all devices with CVE vulnerabilities or device vulnerabilities with high CVEs. So I can preview that, or I can just start it. And what it'll do is it'll show me the options that it's using to filter. So it's actually saying that the Windows patch status does not include installed or removed, and it's looking for anything with a common vulnerability score of greater than 7, which is considered high or above. And what it'll do is it'll bring back the data in this table. So that's what reports look like. When we look at dashboards, we got several default dashboards that are available, and we can create our own. So if we go to the devices dashboard, this will show us a high-level overview of what's going on in our estate regarding devices. Some of these might be a bit slow today. We've also got an applications tab, which allows us to look at all the detailed information about applications. So I can look at all the information about mobile apps, desktop apps, intelligent SDK apps, web apps, mobile apps. I can look at apps by platform, so I can see what's going on inside each platform. I can get a list of top 10 apps and how many times they've been installed, so I can see what the most common apps are. And I can look at any of these in more detail by simply clicking the view button at the bottom of each one. So you can see I can get a lot of information here, even about Windows app errors, so I can see when app crashes have occurred. And I could go into any one of these in more detail, like I said, by just clicking view. It'll show me exactly what's going on. And here you can see that the filter is the app status is installed, managed apps is true, so it's been pushed by Workspace One. And the app platform includes macOS and Windows, and I can see all the devices that have got app software installed. And I've got 119 pages to go through, so I'm not going to bore you with that. See if this dashboard's working now. Come back to that one. The user risk dashboard is the one that I was just talking about a few minutes ago. So this displays any information about users that have displayed any risky behavior, or their device's risk score has increased. So you can see I've got 80 users that have got a high risk score in the last 30 days. I've got thousands that are in medium, and I've got thousands in low. And I can see a graph of this information and see exactly how many have occurred on each day. So that might prompt me to there might have been a particular event on this day which caused a spike. Maybe some users all got the same spam email or something like that. And I can look at any of this data in more detail by clicking on it. When it comes to patches, I've got detailed information about the operating system versions and updates on each platform. So I can look at the OS versions on each Android machine, iOS, Mac OS, Windows Desktop, even some Windows 7 in here, and Chrome, but I haven't got any. So what you can do in here is I could go into the dashboard, I could pick a particular version, and I could set up an automation to remediate or upgrade that particular version to a new version. So if I click on any of these, so for example this one, I can view the dashboard and I can filter further onto the information within that section. Now moving up to security risk, this is showing me the different risks that the platform's identified from the data that's been coming in. So I can look at overall threats, I can look at policy risks, I can look at vulnerabilities, and I can look at device risks. Some of these dashboards are a bit slow to load today. Oh, this one's loaded now. So this is the devices one, so I can look at the mobile device dashboard, I can look at the Windows Desktop dashboard. That little green bit there is Mac OS, by the way. There's not many of those in this environment. I can look at the total devices. I can see which devices are active. I can check and change this graph on the fly. So if I wanted to look at compliance status of all these devices, I can. If I wanted to look at whether they're password compliant, I can do that as well. I can look at device ownership. I can change this as well. So I could maybe change this to look at total physical memory in each device. I could change the device model breakdown to look at something different if I wanted to. All this information is flexible. You can change the time period. You can change the type of graph. And you can really make this look and feel exactly how you want it. Let me just try the security risk dashboard again. So if I click the vulnerabilities tab, I can see this is the vulnerability score that's been used from the CVE database feed. So I can see which devices have got these certain vulnerabilities. I can also get a list of these. So I can see that anything that's above 9 is classed as critical. So I can see I've got all these vulnerabilities that have been identified and they've been picked up by the CVE database. And it's scanning my incoming devices. And I can see that for all these here, I've got 30 devices that have got a critical vulnerability. And I could go into these and I could look in more detail what those devices are, what the patches are, and I can create an automation to remediate those if I wanted to. I can also look at policy risks, so I can see devices without passcodes, devices without encryption, those kind of things. And under devices, I can see those risk scores, so I can see the risk indicators, and I can see what they've been caused by. So, this one's excessive critical CVEs. So the good thing is that looks like it's gone down. So that, from a security point of view, that's a good sign. So on this particular date here, we might have pushed out or automated some patch deployments, which has fixed those vulnerabilities. And some of these threats could be fed in from those trust network partners. So we could be getting threats incoming from places like Carbon Black, and that's telling us which devices might be compromised or affected by the threats. We can also create our own dashboards in here as well, and we can create those by using what we call widgets. So I can come into here and I can create a new dashboard and give it a name. I can save it. I've reached the maximum number in the demo platform. Apologies. I'll show you an example of one that's been created. So what we can do is we can come into here and we can look at this dashboard's been created to look at how many apps have been launched, for example. I can click on this and I can see exactly which apps have been launched. So I can see that these ones, this is the Workspace One UEM console, which is by far the most commonly launched application. And if that's what you want to display in your widgets, then that's fantastic, right? You can also build up multiple widgets within the same dashboard. See if I can find an example of that. Device performance, let's try this one. It's got 6 widgets. So I've got CPU spikes on devices. I've got devices with the most memory reads, so they're obviously the ones consuming the most memory. I've got device processor details, so I can see which processors are in which devices. I can look at average boot duration across all my devices. And I can even see the CPU temperature from within each device. So if some devices are running maybe too hot, which is going to affect the life of the device or maybe make it more prone to failure, I can do something about that by maybe recalling the device. And I can even check on the amount of disk space that's free on these devices, which might be useful because I could trigger an automation to maybe empty the temp folder or some other folders which can be deleted. So these custom dashboards can be created to display anything you want. And they're a really good way of being able to get access to this data in a really easy, meaningful way. Now, the automations that we can create off the back of the dashboards, or we can just come in here and we can create them ourselves. I'll show you some examples. So an example could be this one. We might have identified that some devices are crashing. So what we're going to look for is we're going to look at all the incoming data and we're going to look for a device that's got this particular event in its logs. We're going to look that the process included this and the module included this. If all 3 of those occur, we're going to take 3 actions. We're going to approve a patch to deploy this patch number. We're going to install an internal application, and we're going to send the user a Slack message. And that Slack message says that your device is experiencing a blue screen of death. we are pushing a driver update and a patch to remediate the issue. So we're totally automating the cause of this blue screen of death. Show you some more examples. In this one, we got high risk and anomalous alert activity. So what we might do with this one is we're just simply looking for when a risk score includes high, and we're just creating a service desk ticket to service now. So that's a fairly simple one. We've got some that are linked to carbon black. So for example, this one's found a ransomware threat. So we've got this looking for carbon black feeds. And if a device is found to contain malware and that threat includes this T-ransom, and the threat severity is high, we're going to take 3 actions on this. We're going to install a profile from UEM. We're going to send an email to the user. Carbon Black's reported high severity ransomware attack on the following device. A service now ticket has been raised. Please comply with any and all messages received from the InfoSec regarding the issue. And we're going to log a service desk ticket for somebody to take action against it. So these are all examples of automations that we can take with the Workspace One Intelligence platform. So as you can see, we can use all this information and data that's coming into the platform from a security point of view, and we can automate the responses. And that includes to the devices that can be in people's houses, they can be anywhere, and they'll get those responses and automations in real time. So I hope that was useful. I am at the end of my deck for today, so I will hand back to Stuart and Neil.
Thanks for that session, Darren. Really informative, as all the sessions this week have been, so it's been really good. Thank you again. To our guests, if you have any questions you'd like to ask from what you've seen today, please pop the details in the Q&A or chat box. Clearly it already has engaged some of you, because we have some questions that have come through. The first of which, can you make it prompt a user for MFA only when they're at home, for example?
Absolutely, that's just a conditional access policy. So one of the features of the conditional access policies is that it can check what network a device is coming from when it assesses whether to allow access or not. You can define all your corporate subnets, for example, and if it sees those, it knows that the users are internal. You could say that if it's anything other than those corporate subnets, it's classed as external. So you could challenge for 2-factor. That's completely possible.
Great, thanks, Darren. We've had another question. What type of devices can use the pre-app VPN? Is it only mobile devices?
No, any device type can use per-app VPN. So iOS devices, iPads, iPhones, macOS, Windows 10, they can all use the per-app VPN technology. It's baked into the platform.
That's great, and it's good to know how flexible it is as well. I have a question here that's just come through on the chat box. Some of our computers in production department use software that requires security dongles, i.e. USB stick from a manufacturer to work. How can we deal with this problem in a virtual environment? Can we still authenticate a software application with a secure dongle? It goes on to say, if yes, could we use one security dongle to authenticate the application on multiple virtual desktops at once?
Wow, that's a good question. I like it. So we can pass through USB devices to virtual desktops and apps. That's not a problem. I mean, to be completely honest, you'd have to test whether that particular example works. But certainly, if you plug a USB device into your endpoint, the virtual desktop and app will detect it's there. So if the application detects that the dongle's there, it should work. Now, whether or not you could scale that out to one dongle protecting all those apps and data, I'm not quite sure, because it's usually on a one-to-one basis. But that's something that we could certainly look at.
That's great. And I'm not sure if you've got any more questions through, but certainly one that sounds like we can look at putting something together to investigate that a little further. But if there isn't any more questions now, back to you, Stuart, for a quick poll for your feedback on the session.
Nice one, cheers, Neil, and thanks again, everyone, for your questions. Every session this week, we've been running a poll to find out if we've successfully answered today's big question. Your feedback, as always, is really important to us, and we'd love to know what you think. So here's a very quick poll for you to answer. Here we go, yeah, just appear on the screen, thank you. So to answer using the polling buttons that you should now be able to see on the screen. If they don't appear, please just pop your answer in the chat. So, based on what we've shared with you today, how confident do you feel about VMware's ability to help protect your infrastructure while reducing the number and cost of security apps? If you'd like to place your responses now, that would be great. The choices are very, somewhat, and I still need persuading. We'll just wait for the Zoom machine to do its thing. There it goes. Okay then, right, so let's have a look at these results. So we've got 67%, excellent is very, that's what I like to see, you can come again. 25% of you, okay, need a bit of work, so we've got you covered. Darren is available for hire, so I'm sure we can arrange that with you. And 8% of you, one person still needs persuading, don't we? We'll send the boys round, it's cool, we'll sort you out there. So thanks everyone for that, really appreciate it. Thanks for your feedback. So as I said earlier on, if you missed any of our Big Breakfast webinar series, we're making all of our webinars available and the links will be emailed to you very soon. So you can download and view at your leisure. The topics we've covered, a seamless employee experience, modern management, virtual desktops and apps, and finally today's session, securing the enterprise. Our customers mean the absolute world to us, and the best way, I think, of demonstrating what Kuiper can do is to show you their testimonials. A handful of comments are now on the screen. I'd like to extend our most sincere thanks to you all for joining us today, and for our brilliant speakers from VMware, Paul and Darren, through this week, for showing us the ways in which you can intelligently protect your digital workspace with zero trust security and secure your enterprise. We hope you've enjoyed today, and if you were able to make the other sessions this week, it's given you some real food for thought. We very much look forward to working with you in the near future. Well, this brings an end to our VMware Big Breakfast webinar series. I really do hope we've satisfied your appetite, and we look forward to doing it again soon. So please don't hesitate to reach out to us at any time. We'd love to hear from you. From all of us here at Kuiper and VMware, thanks again for being with us. Take care and enjoy the rest of your day.